So again, welcome to ES1 Synchronous Meeting. First, the usual, I would like to confirm if you can see what's on the screen. It should, you seeing distance between lines na presentation. Yes, okay. So nakikita, thank you. So distance between lines. Ayaw mag-next. Ayan. Objectives natin for this session. After this, you should be able to recognize real-life problems that require the determination of distance and shortest horizontal distance between non-intersecting lines. Also, you should be able to locate the common perpendicular of non-intersecting lines. It goes to say na kapag ilo-locate natin yung common perpendicular, then also dapat alam nyo kung anong ibig sabihin ng common perpendicular. Also, you should be able to apply the concepts of common perpendicular to determine distance between two non-intersecting lines. And lastly, you should be able to construct the segment representing the shortest horizontal distance between two non-intersecting lines. So those are our objectives for today, and let us start with the actual lesson. Let's talk about some concepts about lines. Okay? The common perpendicular of a pair of non-intersecting lines. So here, ang ginawa ko, laser pointer. Ang ginawa ko, pinaghiwalay ko yung kung ano talaga siya in general at saka dun sa in ES1 para meron tayong comparison and maintindihan ninyo kung ano yung implication nitong differences nito. In ES1, a common perpendicular is a segment terminating on the lines. So, ibig sabihin, in this certain example, let's say, kunyari, meron akong line N. This is line N. And also, I have line M. Okay? The common perpendicular terminates sa point X and Y. So, that is the definition of the common perpendicular in ES1. However, strictly speaking, a common perpendicular can be a line or a segment or a ray, not necessarily terminating on the line. So, ibig sabihin, kapag wala ka na sa ES1, the line P, not necessarily terminating on X and Y, line P is also considered as a common perpendicular of lines M and N. Okay? Another, in ES1, common perpendicular is perpendicular to both lines and it intersects the lines. Okay? So ito, kung mapapansin nyo, merong perpendicularity symbol dito. So XY is perpendicular to N. XY is also perpendicular to M. That's why it's called common. Common to both lines and M na perpendicular. And we need to state that in ES1, the common perpendicular should intersect the lines. So Y lies along line M and X lies along line M. However, in strictly speaking, ang kailangan lang nating sabihin, common perpendicular is perpendicular to both lines. We don't need to say na that the common perpendicular intersects the line because in geometry, intersecting the line is a prerequisite for perpendicularity. Pero since sa ES1, 'di ba sa ES1 kahit hindi naman nag-i-intersect, we still consider them perpendicular as long as their directions are perpendicular. So yun. Lastly, pag sinabing common perpendicular, since the common perpendicular in ES1 is a segment that terminates on the line, it can represent the shortest distance between the lines. So, from X to Y, this is the distance between N and M. Okay, the length of XY is the distance between lines N and M. Okay? Sometimes, i-drop ko yung term na shortest. Kasi for me, that's repetitive. Wala tayong sinasabing hindi shortest na distance. When you say distance between two lines, it's automatically shortest. Okay? So when I say distance between two lines, it means the shortest distance between two lines. Okay? To avoid confusion, whenever the common perpendicular is mentioned in this document and in this video lecture, I am referring to the ES1 common perpendicular. Okay? So I'm referring to this para hindi na tayo ma-confuse. I'm just showing you this para alam nyo na in some cases, kasi baka pag dinala nyo yung concept na to in real life kapag nagtatrabaho na kayo, baka ito lang matandaan ninyo, malagot tayo dyan. Okay? Basta alam nyo na alam natin na merong iba pang possible na interpretation for the common perpendicular in real life. Okay. Referring to the example to the right, ito na rin yun. XY with bar, yung merong accent na bar sa taas, kahit walang accent, XY with bar or XY without bar is the common perpendicular of N and M. Pero strictly speaking, XY with a bar on top is a common perpendicular of N and M. P is also perpendicular or common perpendicular of N and M. Notice here, pag nandito ka sa ES1, hindi strict ang paggamit ng bar, whether you mean the line or the length of the line. Pero in reality, kapag nasa formal setting ka na ng, let's say, geometry, kapag walang bar, it means the measure of that segment. Kapag nilagay mo yung bar, it means you are referring to the actual segment. Okay? So XY without the bar is equal to 5 millimeters, for example. Okay? Kapag XY with bar, you can say that XY with bar on top is equal to 5 millimeters. Kasi XY is na may bar sa taas is a line. It's not a measurement. Sana naiintindihan niyo yung gusto kong sabihin. Pero in ES1, it's loosely interchangeable. I don't like it, pero makikita nyo sa plate na sometimes may bar, sometimes wala. So, sir, paano kapag kami na yung sasagot? Hindi ko kayo bibigyan ng deductions kapag hindi nyo sinunod yung actual na use ng bar at saka hindi. Pero I would appreciate kung mapapakita nyo sa akin na alam nyo kung paano gamitin yung may bar at saka hindi. Para naman naiintindihan ko or meron akong feedback na may na-absorb kayo sa akin. Okay, so let us now go to locating the common perpendicular. So this will be our, by the way, ano pala yung mga cases na kailangan nating humanap ng dito, shortest distance between lines. Yung pala, nasa objectives pala natin yun. No? Dapat alam nyo kung ano yung mga pwedeng paggamitan ng shortest distance or distance between lines. For example, kami I'm a mining engineer. So if we construct two tunnels on different elevations running on different directions, then we would like to dig a straight opening na magko-connect dun sa dalawang tunnels. Tapos gusto namin konti lang yung tatanggalin naming materials, then we should be aiming for the shortest distance. That's one example. So that's an example from our field. So actually, as long as gusto nyo ng optimization usually in the form of minimizing length, for example, then that could be an application of shortest distance. Meron ding shortest horizontal distance. Kasi minsan, yung requirement natin, let's say, kunyari, meron kang dalawang bundok. Kunyari lang, no? Very hypothetical. Tapos gusto mong gumawa ng bridge between those two mountains. Okay? And those mountains are represented by, let's say, lines. Siyempre, pag gumawa ka ng bridge, di ka gagawa ng bridge na naka-incline. Diba? So, kapag gumawa ka ng bridge, kailangan horizontal yon. So, you need to find the shortest horizontal distance between the lines representing the mountains. So, yun naman yung application ng shortest horizontal distance. Okay. Going back to this slide, locating the common perpendicular. Again, when I say common perpendicular, I mean the ES1, common perpendicular. So let's recall, dahil we are talking about perpendicular lines, let's recall these two cases kung saan makakapag-conclude tayo na yung dalawang lines or segments are perpendicular with one another. First, if we can see in a reference plane that one of the lines or one of the segments is in true length, and the other is not necessarily in true length, and they appear to be perpendicular on that view, then we can conclude that in 3D space, those two segments are perpendicular. That's one case. Another case is when in a reference plane, we can see one of the segments to be in true length, then the other to be in point view. Then we can also conclude that those two lines are perpendicular on 3D, in 3D space. Okay? So, importante itong dalawang to. Now, let's explore how should the two segments appear in a view so that you could draw a third segment perpendicular to the first two lines. So, ibig sabihin, ano dapat ang itsura ng dalawang given segments natin such that we are able to draw a third line or a third segment perpendicular to both lines. Let's say your first segment, S1, for example, this is S1. So, I'm not drawing the segment. I'm just representing it as this one, S1, is neither in TL nor PV. Okay? So, hindi to TL, hindi to PV. Question, what are the requirements that your third segment should satisfy such to make segment 3 perpendicular to segment 1? Since this is not true length nor PV, we can only apply this requirements or, well, this one. Tama, requirements. Ito lang yung pwede nating gawin para maging perpendicular si S3, si S1. And S1 is not TL, not PV. So ito siya. This represents AB here. Then, ang kailangan nating gawin, S3 should be in TL and also should appear perpendicular to the given S1. Tama? So, ang answer, S3 should be in TL and perpendicular to S1. So if S3 is TL and it is perpendicular to S1 in this view, then we can say that S1 and S3 are perpendicular in 3D space. Yes? Okay. Next, since dito, ito lang ang possible S3 na pwede natin gamitin para magkaroon tayo ng perpendicular sa S1, we need to find kung ano ba ang S2. Ano yung S2? Question next question. If S3 is in TL and is perpendicular to S1, sorry, dapat hindi to L. S1 dapat ito. Perpendicular to S1, what are the requirements for S2 to make S2 or S3 perpendicular to S2 regardless of the orientation of S3? So if this is TL, then we can either make S2 some random line na perpendicular sa kanya. However, hindi natin controlled kasi kung ano ang, kumbaga hindi natin kayang kontrolin yung direction ng S2. Kasi kunyari magpo-project tayo from another view, kung given na sila completely, then the orientation of S2 might not be perpendicular to the S3. So ibig sabihin, we go to this next na requirement. So, ibig sabihin, if we draw S2 as PV, regardless of the orientation of this S3, since TL si S3, kung gagawin nating S2 is point view, then we can have S3 perpendicular to S2 in 3D space. So, ibig sabihin, kaya nating gumawa ng or kaya nating malocate ang common perpendicular if we can have a view wherein one of the line is some random line, hindi TL, hindi PV, basta yung isa, PV. Gets ba? So kaya ba natin yun? Let's say binigyan ko kayo ng dalawang views ng dalawang lines. Kaya ba natin gawin na yung isang line ay gagawing PV? Yes or no? Kaya, di ba? So, madali lang yun. Paano nga? From the top of your head, gagawin natin, we will draw a reference plane parallel to that line. Then it will appear as true length dun sa reference plane na yun. Then next, we will draw another reference plane perpendicular to the true length. Then that line or segment will appear as point view on that view. Regardless kung ano yung maging itsura ng S1, we can satisfy already itong condition na ganito. So, gawin natin. Ito na yun. Therefore, if you can project the segments on a reference plane such that one of the segments is in PV, then you can locate their common perpendicular. This one, hindi to pinakita, pero i-state ko na rin, no? You can also locate the common perpendicular on a reference plane where the segments are both in TL. Figuring out the location and orientation of the common perpendicular in this reference plane will be left to you as an exercise. Naalala nyo sa, I think it's plate number 6, if I'm not mistaken, you were asked to draw a reference plane kung saan parehong TL yung dalawang lines. Diba? So one application of that is looking for common perpendicular. Mamaya, dadaanan natin to. Dito muna tayo sa first bullet. So ito yung example natin. Sample 1, let's locate the common perpendicular. Locate the common perpendicular XY of AB and CD. So this is your AB, CD, AB, and CD. Ano yung steps natin? Yan, sinulat ko na in terms of notations para meron kayong reference kung paano ba siya ginagawa. First step natin, we will draw ARP3 parallel to CD. So this is your CD. Then I drew ARP3 parallel to that. Then we will project AB across ARP3. We will also project CD across ARP3. Hence, meron tayo nito. Okay? Therefore, since ARP3 is parallel to CD, at ARP3, CD will become true length. Ito yun eh. CD is parallel to this, then TL CD dito sa ARP3. Anong susunod? Draw ARP4 perpendicular to CD in TL. Ito lang naman yung CD in TL, di ba? So, I'll draw a reference ARP4 perpendicular to that. And therefore, ARP4 is perpendicular to, at ARP4, CD is in point view. So, dagdagan nyo na lang dito, project AB on ARP4 para i-drawing nyo to. Okay? So, we already have a view, or we already have drawn the reference plane kung saan one of the line is in point view and the other line, I don't care kung ano itsura niya. Basta meron akong point view. So, kapag nakapaggawa na ako ng ganitong view, nasaan ang common perpendicular? Remember, we need to draw a segment perpendicular to both AB and CD. Ano nga ang itsura ng line or segment na perpendicular to a point view? It's always perpendicular to a point view only if that line is in
TL.
Correct. TL. Okay? So, once na meron na tayong TL, meron na tayong perpendicular with respect to CD. Now, how can we make that TL perpendicular to AB? Then we just need to orient that TL such that it is 90 degrees with respect to AB. Tama? Something like that. Okay? So, ang ginawa natin dito, at ARP4, I intersected X and CD. So, yung X nandito. And at ARP4, I drew XY as TL to be perpendicular to AB. So, from X, since meron na akong X dito, andito yung X, nag-drawing ako ng perpendicular with respect to AB, then I can locate point Y. So, XY is perpendicular to AB. Also, XY is perpendicular to CD. Don't forget that you need to write TL. Kasi kapag hindi ito TL, they are automatically not perpendicular to one another. I mean, CD will not be perpendicular to XY, AB will not be perpendicular to XY as well, if this is not TL. Okay? So the next step is to project XY to all of those views. So balik natin sa XY dito, balik natin sa XY dito, balik natin sa XY dito. Now, XY is here. I can project Y. y is somewhere here. Diba? Kasi perpendicular yung projection. However, if I project x, I don't know, well, dapat alam nyo, pero sa unang tingin, hindi natin alam saan ko ba dapat ilagay si x. Nandito ba siya? Nandito ba? Nandito ba? Or nandito? Alam lang natin, x lies along line CD. Pero hindi natin kayang hanapin dito. But luckily, meron tayong information na available. Ano yung information na yon? XY is TL in ARP4. Ano nga ibig sabihin nito? Kapag meron kang TL na project to a reference plane, that line will appear to be
Parallel.
yes, very good. So, nakikita nyo sana yung mga importansya ng mga dati ko pang binabanggit. Itong information na to, hindi to sasabihin sa'yo kung nasan yung X, di ba? You need to figure it out on your own. So, ibig sabihin, you know where Y is sa ARP3, then you just need to draw YX parallel to the YX parallel to ARP4. Okay? So, you know where Y is, you can identify where X is, then project nyo lang dyan. Dito, pagdating naman dito sa ARP2 at saka sa ARP1, unique na yung point kapag nag-project kayo kung nasan yung X and Y. And you will see now kung nasaan ang XY sa lahat ng views. And basically, that's the end of the story if you're just asked to locate the common perpendicular. Kasi ayan na. So, ang instruction lang naman, locate the common perpendicular XY, then I have already located it. Right? Now, what if the question involves additional or follow-up question like this? Ay, sige, mamaya na yon. Things to ponder muna tayo. When reporting the distance between lines, from which reference plane should you measure the length of the common perpendicular? Balikan natin yung example, no? Ayan. So, saan ako magme-measure ng length? Kasi meron akong 4 views. In all 4 views, I can see XY, which is my common perpendicular. Kapag pinareport sa iyo yung measurement, saan ako kukuha ng measurement? ARP1, ARP2, ARP3, or ARP4? Then tell me why. So, merong sagot na ARP4. Why ARP4? Yun. Yun. Okay, very good. Yan. Salamat sa mga reply. You should take the measurement where it is true length. And obviously, it's true length here, then we should take the measurement from here. Okay? Importante yun. Kasi baka kapag nakita nyo siya dyan lahat, bigla ka na lang mag-measure dyan, tapos i-report mo yung length nun, deads ka. Okay? Remember, you can only measure the length of a segment wherein it is shown in true length. So that's one. That's the first one. Next thing to ponder. What is the distance between intersecting lines? Can somebody give me an answer? Distance between intersecting lines. If the lines intersect, the distance is 0. Correct. Walang distance. That's why kapag binalikan nyo tong slides na to, nakasulat dyan, distance between non-intersecting lines. Kasi automatically, if those two lines intersect, then the distance between them is 0. Last, do parallel lines have common perpendiculars? Yes or no? Yes. In fact, so the answer here is yes. In fact, unlike skew lines, pag skew lines kasi you have only one common perpendicular. However, when you have parallel lines, you can have multiple common perpendiculars. Kasi, well, you can draw infinitely many common perpendiculars kapag parallel sila. Okay? So, yun lang. Yung things to ponder. Balik tayo dito sa slides natin. Ito yun, ano? Kunyari, merong additional na question. What is the distance between AB and CD? Then, distance between AB and CD is equal to XY, which is equal to the measurement of XY in TL, then equals something in millimeters. Okay? So, pagdating sa slide, sa plates, kapag merong measurement na hinahanap, anong kailangan gawin? You need to draw your scale. Okay? The scale can be of any orientation. Basta ilagay nyo doon for 10 millimeters. So, kahit hanggang 30 millimeters siguro. Para lang kahit na hindi man namin ma-measure ng actual, we can have a relative way of checking kung tama ba yung nakuha yung measurement. Okay tayo? Let's proceed. Hi. Oops, sorry. Okay. Itong ARP5, in this certain example, this is not required to be drawn. Okay? However, I'm drawing this because, babalik ko lang, naalala nyo, nakasulat dito, you can also locate the common perpendicular on a reference plane where the segments are both in true length. So, ibig sabihin, sa view na to, syempre kung ARP5 is parallel to AB and CD's point view here, AB will become TL and CD will become TL as well. So, ito yung view na minimension nung example na yon. However, since you can already determine the common perpendicular in ARP4, so why bother drawing ARP5? Diba? Ang sagot dyan, yung pag-drawing natin ng dalawang TL, well, hindi ito yung way. I mean, there's another way of drawing your TL such that instead of adding 1, 2, 3 additional views, you will only add 2 additional views. Okay, so this is an alternative solution. And we will show it here. So for example, ito yung instructions. By adding at most 2 reference planes, show the segments in true length in one view. Ano yung steps na gagawin natin? Sinulat ko na, no? At ARP1, you will draw CE such that it is parallel to AB. Okay? So I have C here. Then I'll just draw a line E. Walang requirement CE kung nasaan. Diba? Kahit saan. Kung saan mo gustong ilagay CE. As long as CE is parallel to AB. And then, you will also draw in ARP2, CE to become parallel to AB. So meron akong C dito. I'll draw CE parallel to AB. Of course, kung nasan yung E dito, dapat nakaproject siya, pareho lang ng point dun sa E. So kung yung E mo, nilagay mo lang dito banda, dapat dito yung E, nandito lang din banda. Intindihan ba? So the only requirement is that CE is parallel to AB in two planes, in two reference planes. Of course, this will not work kung naka-perpendicular yung AB sa reference plane. Kasi we need to conclude that CE is parallel to AB. Okay? So CE is parallel to AB kasi two views, nakita ko na silang parallel with each other. Then we can conclude that the line is parallel to the other line. Also, since the line CE is within or is an element of plane CDE, therefore, we can also say that the plane CDE is parallel to AB. So in this case, CDE is parallel to AB in 3D space. Okay? So what will happen? Bakit kung gusto silang gawing parallel? Mamaya makikita ninyo, no? Sobra yata ako ng sinulat. Sobra nga ako ng sinulat. Anyway, so yung kadugtong niyan, ito. Ay, sorry. Tama, tama, tama. Balik ko lang ha, sorry. Ito pa pala, no? At ARP1, I'll draw a CF parallel to ARP2. Then, yung CF na yon, pag lumabas dito, magiging true length. O dapat may TL na nakasulat dito. Hindi ko na isulat. Pero nandito siya. Dapat huwag niyong kalimutan. So kung i-grade niyo itong ginawa kong presentation, may deductions na agad. Wala nakasulat ng TL. Okay? So CF is TL here. Kasi CF here is parallel to ARP2. Yan. So anong gagawin natin? Once na meron ka ng true length dito, we will draw ARP3 to be perpendicular to CF. So ito yung CF. So we will draw this ARP3 perpendicular to the CF. Ano mangyayari? If ARP3 is perpendicular to a true length within a plane, then that plane will become edge view. Since that plane is parallel to AB, when the plane becomes edge view, you will see AB as a line parallel to the edge view. Ayan. So mukha silang parallel dito kasi parallel sila eh. Pinorse natin silang mag-parallel dito. Diba? Since you already have CD and in edge view and line AB parallel to that CDE, then let's draw a reference plane, ARP4, parallel to AB or parallel to EV. Ito yan, ARP4 parallel to AB. Then what will happen? When we project, CDE will become true shape, AB will become true length. Let me check the chat. Sir, hindi po ba i-indicate sa ang CF dapat perpendicular yung ARP3? Correct. So, yun nga. Thank you for that clarification. Itong nakasulat dito, ARP3 should be perpendicular to CF, TL. Thank you, Vince. So, dapat may nakasulat dito, TL, para masabi natin itong ARP3 perpendicular sa CF na to. Yan. So, nagpa-pile up na yung errors nung ginagawa ko dahil di ko na ilagay yung TL. So, expect nyo rin kapag kayo, malamang magpa-pile up din yan. Thank you for that reminder. Anyway, going back, AB is already in TL. Hindi po need nung add po. Hindi. Dito sa pag-draw. Kasi you are drawing the reference plane itself. You are not drawing on the reference plane. So dito, AB is in true length. CDE is in true size or true shape. Ano nga ang property ng true shape na plane? Lahat ng lines sa true shape na plane ay naka-true length. Therefore, CD is also true length in this view. So I have here TL, AB, so AB TL, and CD is also TL. So I will leave to you as an exercise to locate the common perpendicular. Ang gusto ko lang sabihin, hindi ko papakita sa slide. Pero I will ask you now, nasaan ang common perpendicular ng dalawang lines, segments, AB and CD? Can someone answer? Punta tayo dito. May true length ako. May true length ako. Anong itsura ng line na perpendicular sa true length? Naka 90 degrees? Yes, that could be a possible. However, kapag gumawa ako ng line na naka 90 degrees with respect to AB, can I draw that such that it's also at 90 degrees with respect to CD? I can. Kasi kapag, kunyari, sa example na to, If I draw a line perpendicular to AB, that's automatically not perpendicular with respect to CD. What else? Thank you for that attempt. Okay, that's a good question. Yung intersection niya po, okay. That's the correct answer. Ang tanong na lang, why? Why is the intersection the common perpendicular? The answer is another form of a line that could be perpendicular to a TL is point view, di ba? Yun. Kasi PB is perpendicular to TL. If I assign this intersection as the point view of the common perpendicular, then that point view is perpendicular to AB and it is also perpendicular to CD. And also, it intersects AB and CD. O, di ba? Daming na-hit sa isang line. So, the common perpendicular is here, shown in PV in ARP 4. Okay? So, pag pinroject nyo yan, anong itsura niyan? Makikita nyo, pag pinroject nyo yan dito, makikita nyo siya dito as perpendicular doon sa EV at saka doon sa AB. Pag ganun siya. Di ba? Somewhere here. Hindi ko siya ito-drawing kasi kailangan ma-figure out nyo yan on your own. Then, populate all the views. Meaning, if I'm looking for XY, let's say XY yung common perpendicular, you need to draw XY here, XY here, XY here, and XY here. Again, the question would be, ayaw mag-move. Mamaya. The question would be, saan kayo magme-measure ng length? Kapag ito yung method na ginamit ninyo, saang reference plane kayo magme-measure ng length? Well, the answer is just look for the view wherein the common perpendicular appears through length. And since point view siya dito, it goes to say na kapag pinroject ko yung point view across the reference plane, it will appear as true length. So it will become true length here. Then you should measure the distance between the lines or the segments in this view. Okay. Question about shortest distance and common perpendicular before we proceed to shortest horizontal distance. Please send to the chat if it is clear or if you have questions. Question, sir, yung PV po ba necessary na andun lang po sa intersection? Yes, kasi nandyan siya para ma-intersect niya yung dalawang lines. Kung mapapansin nyo, dahil babalik ko yung slide, kung mapapansin nyo, this is the only position kung saan kapag gumawa ako ng point, it will become an element of both AB and CD. Diba? Kapag dito ko nilagay banda, yung point view, then this will not intersect AB. Eh di ba ang requirement for perpendicularity? Dapat mag-intersect siya. So kailangan ma-intersect ng PV natin yung AB at saka CD. We cannot put it here. Pag dyan natin nilagay, yes, that point view is perpendicular. In definition of ES1, perpendicular yung direction niya with AB and CD. However, if it is not intersecting, then it's not the common perpendicular. Hindi pwede dito kasi hindi siya perpendicular o hindi siya intersecting with AB. Hindi rin siya pwede dito kasi hindi naman siya intersecting with CD. Dito lang siya pwede. In this case, it's perpendicular and intersecting to both AB and CD. Question. Perpendicular lines in 3D. 3D space are not necessarily intersecting in 3D space. Tama po ba, sir? So they can't be classified as intersecting line agad po. If you are pertaining to ES1, the answer is they don't need to be intersecting. Pero in geometry, they are required to be intersecting to become perpendicular. Yun nga, kaya ako merong kumbaga parang initial statement dun sa start nung slides na kapag ES1, ang definition kasi ng perpendicular lines sa ES1 is their directions are perpendicular. Pag ganon, they don't need to be intersecting in 3D space. Pero in geometry, they need to intersect to be considered perpendicular. Any other questions before I move on? Kung walang questions, can you please type na clear na or we can proceed? Para naman alam ko kung I'm waiting for responses or other, baka kasi may nagtatype pa sa inyo. Clear na sir? Clear na po? Thank you. 1, 2, 3. Proceed na po sir. Okay. Nakalima na ako. Kalahati na yan ng mga nandito. So, let's proceed. Okay, measuring the shortest horizontal distance. Let's say A, B, and C, D are given in FRP and HRP. Please take note, it is important na i-note nyo to. This method works by drawing additional reference planes from HRP, not FRP, not PRP, and not ARP, but HRP. Meaning we can only determine the shortest horizontal distance if we continue working from here. So pag gumawa ko ng additional reference plane, dapat nakadugtong siya dito. So pwedeng dito or dito. Hindi pwede dito. Hindi pwede dito. Mamaya papakita natin kung bakit. Okay. Compare lang natin, no? We have here, ito yung methods for steps for the shortest distance. Diba? Dala nyo? Anong ginawa natin sa shortest distance? Gumawa ako ng line CE parallel to AB. Gumawa ako dito ng line CE parallel to AB. Then CDE is parallel to AB. Gagawa ako ng line na perpendicular to a true length na hindi ko na pinakita dito, such that pagdating sa ARP1, CDE is edge view and is parallel to AB. Then gagawa ako ng reference plane parallel to those lines. Then magiging TS si ABC, si CDE, and then BA or AB is in true length. Then I can identify the shortest distance or the common perpendicular. Okay? Ito yan. Bakit ko ulit pinapakita? Kasi gusto kong ma-differentiate nyo siya sa method ng paghanap ng shortest horizontal distance. So, notice here that ARP2, ginawa natin siya such that it is parallel to the edge view. However, if we are going to find the shortest horizontal distance, instead na i-drawing natin yung ARP2 na parallel dun sa edge view, we will draw ARP2 such that it is perpendicular to ARP1. So this is your ARP1. We will draw ARP2 perpendicular dito sa ARP1. Ito yung difference nila. Draw ARP2 perpendicular to ARP1. Then, kapag meron ka na yan, project. So you will have CDE here. CDE is not true size or true shape here, right? AB is not true length as well. But if I assign the intersection as the point view, what will happen? Okay? So let's say, sabi ko, XY here is point view. If it is point view here, it goes to say that if I project that point view, pabalik dito sa ARP1, XY will become true length. Tama? If XY is true length here, then, pagdating dito, pag pinroject ko siya dito sa kabila, this line, the line XY will become parallel to HRP. So ulit, ito, pinroject ko across this reference plane HRP. Then paglabas niya dito, dapat parallel siya. So ito ay parallel dito. However, from point view, pag gumawa ako ng true length dito, or pag pinroject ko, yung true length na yan, perpendicular siya dito, di ba? Eh, itong line na to, or yung reference plane na to, perpendicular siya dun sa reference plane na to. Therefore, this segment is parallel to this reference plane. Pero kapag lumabas yung line sa kabila, parallel din to. So, ibig sabihin, itong XY, parallel siya dito, parallel din siya dito. So, itong tatlong lines na to, parallel sila. So, meron akong line dito, parallel sa reference plane, true length siya dito. Meron akong line dito, parallel sa reference plane, true length din siya dun sa kabila. Kita nyo ba? So, may true length siya dito, true length din siya dito. Okay? So, bakit ko gustong gawing true length dito yung line? Kasi, kung meron akong true length dito, automatically, if I project it across the frontal reference plane, the line will appear parallel to the frontal reference plane. Kung parallel siya dito, parallel to horizontal reference plane. Etong line na to, kung parallel siya sa HRP, then this is parallel. This is horizontal, which is what I'm looking for. Horizontal distance. Shortest horizontal distance. So yun. XY now is horizontal in FRP. Tapos true length siya dito. So yun. That's how this method works. So, additional things to think about when reporting the shortest horizontal distance between lines. From which RP should you measure the length of the common perpendicular? Hindi siya common perpendicular. Should you measure the length of the segment representing the shortest horizontal distance? Balik ko yung slide. This is not a common perpendicular, ha? Malinaw ba? It's a segment representing the shortest horizontal distance. Okay? So yun. Yan siya. So, saan tayo magme-measure? We can measure it here, and we can also measure it here. They should have the same length. Kung magkaiba ka ng measurement na nakuha dyan, ibig sabihin may inaccuracy kang nagawa. Okay? Kasi TL siya dito, they should have the same length. What is the shortest horizontal distance between intersecting lines? So, similarly, 0 pa din ang horizontal distance ng intersecting lines. Last question, do parallel lines always have the shortest horizontal distance? Yan. This one, I would like you to answer through chat. Do parallel lines always have the shortest horizontal distance? Pwede kayo mag-guess. No po. No? Okay, sige, okay na siguro to. May dalawan lang sumagot. The answer is no. You're correct in saying that they do not always have shortest horizontal distance. Ano yung case kung saan hindi sila magkakaroon ng shortest horizontal distance? Kapag those lines, let's say kunyari, horizontal yung lines mo, tapos magkaiba sila ng elevation. Kapag magkaiba sila ng elevation, tapos horizontal sila, then they will not have horizontal distance at all. Kasi kahit anong horizontal segment ang gawin mo, hindi sila mag-meet. Okay? So wala. They don't always have shortest horizontal distance pag parallel sila. But of course, there are cases na pwede silang magkaroon ng shortest horizontal distance. So recap natin yung objective. You were After this, you should be able to recognize real-life problems that require determination of distance and shortest horizontal distance between non-intersecting lines. I think we already achieved this. Also, you should be able to locate the common perpendicular of non-intersecting lines. I think nakuha na rin natin. Apply the concepts of common perpendicular to determine the distance between two non-intersecting lines. Okay na rin to. Lastly, construct the segment representing the shortest horizontal distance between two non-intersecting lines. Nakuha rin natin yan. So, I guess it's a success for this synchronous meeting since we've reached all of our objectives for this lesson. So that's actually the end of the presentations. I am now ready to entertain questions about the lecture muna. If you don't have questions, can you please write on the chat box na wala na pong question so that I know I'm not waiting for typing. No questions po. One, two. Does that mean clear yung explanation or no question kasi sobrang gulo, wala ako may tanong? Ayan. Sir, yung pagkuha po ulit ng shortest horizontal distance, pwede po pa-explain ng punti po ulit. Okay. Let's go back. Ayan. So dito sa sa slide na to, ito yung method natin ng pagkuha ng shortest horizontal distance. The steps are as follows. First, you need to note that this method works only when you continue working from HRP. Okay? Hindi pwedeng dito tayo dudugtong. Dito dapat magdugtong. So dapat yung ARP1 is attached to HRP. So anong gagawin natin? Same lang nung ginawa natin dun sa shortest distance. We need to make the plane edge view. Oh, dapat pala may nakasulat dito, edge view. Okay? So we need to make the plane as edge view. And the line will follow as a line parallel to that edge view. Diba? The next step would be to create a reference plane parallel to ARP1. So yun yung crucial doon. Yung ARP2 na ginawa dito, at parallel tuloy, sorry, cross that, perpendicular to ARP1. So you need to make ARP2 perpendicular to ARP1. And after you project, you're almost good as finished. Kasi, once na pinroject mo yun doon, you just assign the intersection of the two lines as PV of the shortest horizontal distance segment. Okay? Then, project mo lang. TL, kasi point view doon, so magiging TL dito. Then, TL na parallel sa reference plane, lalabas siya as TL pa rin uli dito. So, dahil TL to, pag lumabas sa reference plane, magiging parallel sa reference plane. And since this reference plane is horizontal, then XY will become horizontal sa front view. Then, that's the horizontal distance. And it is the shortest. Clear, Vince? Saan po ulit yung i-measure po dyan? Okay, I will return the question to you. Sige nga, saan yung i-measure dyan? Pag tinanong na, what is the shortest horizontal distance between AB and CD? What's your guess? Saan natin i-measure? Yes, HRP is one of the two correct answers. Saan pa pwede? Correct din. So the question would be Bakit pwede sa HRP at bakit pwede sa ARP1? Anong meron dun sa mga views na yon kung bakit pwede ako mag-measure sa planes, sa reference planes na yon? Very good. Okay? So at least now, I'm not just telling you, okay, measure from HRP or measure from ARP1. Now you know why, kung bakit doon tayo nagme-measure. And that's more important than telling you kung ano yung reference plane mismo. Mas importante na alam nyo kung ano yung hahanapin nyo para ma-identify nyo kung saan kayo magme-measure. Okay? How about the rest? So walang questions dun sa iba. Sige, so mukhang okay. So sir, basta i-follow yung process na yan po, then kung alin yung TL, ay yun ang i-measure po. Yes, that's correct. Okay. That's the end of this lecture. Sir, i-upload nyo po ba itong slides? Of course. Ikaw pa, malakas ka sa akin. Upload ko yung slides, upload ko yung Zoom recording para masaya tayong lahat. Okay ba yun? Uy, maaga ako mag-upload. As in, pagkatapos nung meeting niya, upload ko kaya. Okay. You want this to be uploaded before discussions. Okay. Sige. I will. Para mas madali po mag-notes. That's actually a good idea. Okay. I will upload the slides before the start of the meeting. Para meron kayong reference na pwede nyong lagyan ng notes during lecture. Okay. Going back, another question, sir. To consider lines as intersecting, they must intersect in 3D space. Tama po ba? And kapag hindi sila intersecting, kahit na perpendicular direction nila, hindi pwedeng i-classify as intersecting lines. Yes. Correct. Basta hindi sila intersecting in 3D space, sa ES1, basta kahit perpendicular pa sila, kasi nga sa perpendicular ng ES1, we mean perpendicular yung direction, hindi nagre-require na intersecting sila. Okay, I'm not getting responses from other students. So I guess I will dismiss you now. So again, thank you for attending the lecture for today. And if you do not have any questions, you may start leaving the synchronous meeting. Thank you for attending. Sir, I tried studying po yung sa Ublin na materials, hindi ko po naiintindihan. Okay. Kunyari, hindi ko nabasa yun. Dito, that's why I'm providing you with additional... Pero naiintindihan mo naman itong diniscuss ko, Patrice? Okay. Mabuti. Ang importante, merong way para maintindihan natin yung next. Sige. So, yeah. That would be all for today. You may start leaving if you do not have any questions. If you have questions, you may leave and just keep on asking questions.